In this lesson, I'm going to give a brief overview of messaging systems and real-time big data processing. I'll introduce you to Kafka and we'll get it installed. First, let's talk about real-time processing and messaging. So what's messaging good for? It's good for long-running tasks, things that you wouldn't want to run inside of a request-response lifecycle. It's good for managing bursty events. So if you have a high traffic event and a lot of things come in that don't need to be processed right away, they can back up in a messaging queue and that's okay, and it won't cause your entire system to fail. It's good for decoupling services. So if you're writing data into a messaging system, services that are interested in that data can subscribe to it and pull it out, so the two services don't have to talk directly to one another. And finally, it's good for denormalizing or copying data. If you have a messaging system with pub/sub semantics, which I'll explain later, it allows you to write the data in once and then pull it out to multiple services and create copies of it. So let's talk a little bit about the semantics of a messaging system. First, you have producers or publishers. These are the things that are going to be writing data out to the messaging system. Secondly, you have brokers or queues. So brokers are usually a centralized component that are responsible for taking in messages and either sending them out to consumers or responding to consumers' requests for messages. And oftentimes you can think of those as logical queues where messages go in and then consumers pull them out. So then we have consumers or workers which connect directly to the brokers and request messages that they then process and do something with. So most messaging systems have a first in, first out kind of system, where if you write a message in, it goes into a queue, and if messages back up, when consumers request a message, they'll get the first one that went into the queue. So let's talk a little bit about Kafka. It's distributed, and it's meant to be distributed at every level. That is, you're meant to have multiple producers running on multiple machines, multiple brokers running on multiple machines, and multiple consumers running on multiple machines. It's persistent, which means messages that you write into the broker get stored there so that they can later be replayed by the consumers. It's designed to be very high throughput. So when they had to make a choice about whether or not to include features or to optimize for throughput, LinkedIn opted for throughput. Kafka implements queues through topics. So you write messages to a topic, and then consumers can then pull messages from various topics. Finally, it's open source, and it's in the Apache incubator right now. It was originally built at LinkedIn to handle their high traffic messages for events and users, activities, and things that they click on. So there are many messaging systems you can use. Here are a few of them. RabbitMQ is one. Kestrel is another that was built at Twitter. Redis, even though it's a data store, can be used also as a messaging system. ZeroMQ is another type of messaging system. It's a little bit different than Kafka or Rabbit or Kestrel or Redis because the zero means it's supposed to have zero brokers. It's brokerless, although it's a set of low-level tools that you can use for messaging, and you can build your own brokers. But enough about those other messaging systems. Let's get to Kafka and actually install it. So we're back on our EC2 instance, and the first thing we're going to want to do is to download Kafka. I pasted the command in here to get the source code. Now we need to unzip it. And we're going to need to build it. Now Kafka is written in Scala, so we're going to use Scala's build tool called SBT. Update tells it to get all the packages necessary to build the project. Now that we've downloaded the dependencies, let's build it. Again, we're using the Scala build tool to package up the project. Now that we've packaged the project, we're ready to start it up. Now Kafka has one primary dependency, which is Zookeeper. Zookeeper is also a project within the Hadoop ecosystem. It's designed for distributed coordination. Kafka uses Zookeeper to distribute between the brokers which ones are up and which ones are responsible for the topics that are being published into the queue. So let's start up Zookeeper right now. Normally you'd want to have some sort of startup script in initd, but we're going to shortcut this for the examples and make it easier. And we'll redirect standard error to standard out and store it all in a file called Zookeeper out. Oh. Let's try that again and actually background the process. Now let's see if Zookeeper is running. All right, there it is. So now that Zookeeper is up, we're ready to start up Kafka itself. Now we're just going to use the default server properties file that comes with the project. That's good enough for now. We'll redirect standard error to standard out and point it all at this log file. All right, let's see if Kafka's running. And that looks good. So let's take a quick look at the server properties file and see what there is here that we can configure. We see that there's a broker ID. Now when you're running Kafka on multiple servers, each broker must have a unique ID. The port it runs on by default is 9092. The number of threads it takes, optimizations for how much you can send and receive on the network, the directory that it stores its logs in, the number of partitions, which we'll actually cover in a later lesson, and how often Kafka is going to flush the log to disk. Now that Kafka is installed and set up, we're ready to move on to the next pieces. So that does it for this lesson. We've covered an introduction to messaging and how it's useful in a distributed system, and also how to install Kafka. Messaging should be a part of any robust big data system. It allows you to copy data from one service to another and respond to events in real time. In the next lesson, we'll actually create a message producer and work with Ruby code that interfaces with Kafka directly.